Hello everyone, my name is Alexander. I will be presenting my final project in the algorithmic programming in Java in the School of Computer Science at the College of Management. So let's begin. In my project, I've used algorithmic programming in maze generation by using a simple and the Goriachnick algorithms, and in maze solving by using DFS and BFS algorithms. I've used the following design patterns: adapter to make an interface that adapts the maze to be a searchable problem, MVC and MVP for separation of concerns to divide the code into layers to allow each layer to be responsible for its unique role, MVP is used with the observer to allow each layer to notify others about changes. The decorator design pattern allows using a specific algorithm to save a maze in more compact form. The project can be run with two user interfaces, the command line interface and graphical interface using SWT. This allows the game to be cross-platform. Object serialization is used to load and save mazes and solutions. XML decoder is used to save and load properties XML that control how the application runs. Additionally, threads are used to allow all time-consuming tasks to be divided into threads, so that several tasks can be run simultaneously without blocking the UI. Let's go over the code a bit. We can see in the MVC, in the CLI manager, we see the command manager, which contains all the commands that the CLI can take. We see the controller, we see the model, and we see the view. The model is responsible to making all the maze generation, maze solving, etc. And the view to show, notify if maze is ready, notify something, and display some output to the user. Additionally, we see the MVP, which is for the graphical user interface. See, we have the same command manager with different commands. We have the model, which is to save solutions, load solutions, solve maze, etc. And we have the view, the maze window, which implements we use it to display all the data. Okay, in the algorithms, as I've shown you in the demo, we have the maze adapter that adapts the maze to be searchable, and in the demo here we use the adapter to use different algorithms, BFS and DFS, to get solutions. Let's talk a bit about the BFS algorithm. The BFS, best first search, uses the priority queue of the nodes that are to be checked, so it always checks for the best nodes. We keep track of all the nodes that are to be checked and all the nodes that were checked previously. Each node has a priority, which is the cost to get to this node from the start. Higher priority means lower cost. Let's go over the pseudocode. We start with the start position and we add it to the open list. In the main loop, we go over all the nodes in the open list. We pull one node. If we reach the goal, we backtrack to return the solution. Otherwise, we go over all the neighbors of the current state. If the neighbor wasn't evaluated, we record its cost and how we found it. Then we add it to the list to be checked. If the neighbor was visited, we re-evaluate its cost because we are looking for the best first search. If it's better, then we set it. If the node is new to us, and we just need to add it to the list that needs to be checked. And here is the block diagram of the algorithm. Let's go over the algorithm as it's written. This is search. We take the start state. If it's not null, we go add it to the open list, and once it's not done and the list is not empty, we pull, as I showed you, which is the priority queue function. So we add it to the closed because we are evaluating it now. We get the ghost and see that it's not the exit. If it's exit, we backtrace. We get all the neighbors, and for all the neighbors we go and see that it's not in the open list and it's not in closed, which means we didn't cover it, and we set it that we came from here. We set its cost and we add it to the open list to be checked afterwards. And if the otherwise, if the node was evaluated, we get the new cost and we check if the new cost is better. If so, we set it. If the open list, if we didn't add it to the open list before that, we add it now. Otherwise, we need to notify the priority queue about the change that was made with the new cost. Let's run the application. We'll start with the GUI, as can be seen in the properties XML. Okay, let's generate one maze. Let's call it test 1, 2. Okay, a person can play the game using arrow keys for moving inside the floor and using page up and page down to go up or down the floor. If the person is stuck, he can ask for the computer to solve the maze. Okay, we see that the maze is solved. Let's exit now and switch to CLI view. Save and run the application. Okay, we can display the maze that was created earlier. We can generate a new one. And we can generate another one to see that it is multi-threaded. It's running simultaneously without any problems. We can exit now. Thank you for watching. Bye bye.